Good morning. Welcome to California Seismograph. We're glad you're with us this morning. We had an earthquake at Octilio Wells, and today I want to take you to a couple things. We do a little of a educational video about it, and because a lot of people have had questions and I haven't been able to really answer all of it. But this morning, early in the morning, at 5:48:53 seconds, we had a 4.1 earthquake. It says the 3.9 because it did get downgraded at Octilio Wells. As today, we were lucky enough to have this occur quite early in the morning, this earthquake. And let me take you back to the earthquake here. Like you see, it's a nice graph, but recognize the time at 5:50. This occurred at 5:48, of course, and our setting at that moment was 1550, which is in the daytime, as you guys know, is about around 500, 550 max. So we're 1,000 points higher in sensitivity. And that was our luck, being able to get this nice graph out of this earthquake this morning. Obviously, as you see, the Lake Matthews, the ends of the Tuscamal Valley and the San Diego all turned red, and they both show up there very nicely too. Now, the next question I get is the difference. If you look, and I back this up a little bit, and you look at this earthquake, how long stretch this is. Remember, this what you see here on the top graph, on the ground measurements, you see this minute tick here. All these are the minute ticks. Every bar is exactly a minute in between. And if you look at this coming down here, you see that this earthquake tends to be showing about 2 minutes long, or a minute and a half at least here. Which is correct. And let me explain this a little bit. What happens is we are in a low sediment area where the soil is real soft. And when you have a very soft soil, it has the tendency of vibrating and revibrating and bouncing off in this ball and giving a lot longer of a stretched measurement of this quake. Because up here, as you see, this is probably only like 15 seconds, 20 seconds. Well, this is a minute and a half. And so that has to do with, they're further up in the mountains, both Lake Matthews, Mescal Valley, they're, against or on some solid ground there. So here it shows up as the 4.1 Octilio Wells. Let's go back and look at a couple other things we have going here. Let's look at our fault map. We have the earthquake occurred right here on the bottom end of Coyote Creek Fault, of the Coyote Creek Fault, right there. And as you see, the red, as a matter of fact, this is the most common occurrence of earthquakes, color red, and that's right on the edge here. We see this happen and occur quite often, quakes here. So let's look at another thing on this map here, and it's something that I personally have been looking at, and I don't know many people I've ever heard talking about this, but we all know that the San Andreas fault here, you see, it's a slip strike fault, and it's known to be that. Now, we do have thrust faults, and one of the thrust faults areas, and I think on this map it kind of really depicts it. If you look in front of San Luis Obispo here, at this type of fault structure here, then this indicates to me the pressure of the plate coming this way. As a matter of fact, our mountain line indicates a lot of that. As you see here, this thrust line here shows that this mountain range is kind of almost stopped right here, where we have our plateau area and the mountains here, which all thrusts up into the eastern Pacific plate. And so, interestingly enough, we got